So, ladies and gentlemen, I'd like to warmly welcome you to this session on human-centric twin transition across the European innovation programs. My name is Filip Piatkiewicz, and I'm the Secretary General of ADRA, the AI Data Robotics Association, which is the private side of the public-private partnership with the European Commission. ADRA representing the private side. Anyway, today's session isn't about me. I wanted to introduce all of our guests here in just a moment, but I have the absolute pleasure of an honor of moderating what will be a really fascinating conversation across various disciplines, innovative solutions, approaches, and this session will be divided into two parts. The first of which will give us a bit of context setting into what the twin transition is, how various actors are approaching it, and it will reflect kind of some of the strategic and visionary approaches that are being used to tackle societal challenges that simultaneously advance environmental, sustainable, and digital innovations. In the second half, we're going to be welcoming our guests who will focus on use cases, and they'll present and discuss some of the requirements for overcoming barriers in collaborating across fields and disciplines, how Europe is kind of aspiring to project some of these ambitions globally, especially in response to the Sustainable Development Goals, and how we identify and improve best practices in an environment of ever-accelerating technological innovation. So I'd like to welcome our first three speakers who are going to be tackling, setting a bit of context for us. So we have Ennio Chiatante, who is the head of funded projects and institutional relations at Comau. We have Weimar Bolhuis, who is going to be looking at human-centric aspects in the transition and represents TNO. And then finally, we have Ilias Lekovidis, who is an advisor on digital aspects of the green transition at DG Connect. But our first speaker will be Ennio Chiatante, who's going to be covering the twin transition from the perspective of industrial automation. So thanks very much, Ennio.
Thank you. So what I'm going to attempt to do in this brief time available is to talk to you about the approach that Comau has had to the twin transition and the approach to the funding programs for innovation. So first of all, a little bit of story of who Comau is. Comau is an industrial automation products and solutions provider. It was born 50 years ago and has undergone an evolution throughout these years. We were born basically as a provider for the automotive sector and have expanded globally and also differentiated in other markets. Having innovation always and research and development always as a backbone of our transition. The industrial automation is an everly growing sector. This is a projected annual growth rate for the next years. Traditionally, the automotive sector was one of the biggest users of industrial automation, but as you see from this chart, now other industries are growing even much quicker than what the automotive sector is. And in Comau, we believe that the most effective way we can support the twin transition is through providing our products and our solutions to industrial manufacturers that can then have the advantages of what industrial automation can bring. So these are the main benefits of industrial automation and what our users can actually expect to have. So basically a bigger efficiency, better throughput, better quality in the products, so reducing waste, and also increase safety, and that's where the human part comes in. As I said earlier, we were lucky enough to be working for the automotive sectors for many years, and when the electrification transition hit the automotive sector, which is a very important sector in Europe, as we heard from the opening remarks this morning, we were in the right place to start working on this and supporting our customers with the transition to electrification. This also gave us the opportunity to enter new markets through the same technologies that we were developing for the automotive. And sorry, we are missing. Okay. There was supposed to be a picture here of a station that we developed for dismantling of automotive battery packs. This was an innovation program co-funded by the European Commission through one of the funding schemes, and was developed on a European consortium, including also end users and RTOs. And it also looks much more in the future, so at the dismantling of the battery packs from automotive at their end of life. With the capability of dismantling different automotive packs, as they are all one different from the other, so utilizing digital technologies, vision systems to adapt the robotic station to the actual battery pack that is presented within the station. Not only that, but in developing this solution, we also developed load code programming that enables also users that do not have or have not been skilled in robot programming to actually program the station with much simpler interfaces for the human to be able to interact with the automation, which is still rather complex. So here the digital aspect comes in help of the human in being able to have a better interface, human-machine interface. A different sector that we have been approaching is that of automating in unstructured environments. This is particularly true for renewable energy sector, but not only. And here again, we developed a solution for installing solar panels, again through a co-funded program, European co-funded program, with the end user involved in the co-funded program. And again, solutions that are in support of the operators that would be installing these in remote areas of the world where the harvesting of solar power is more efficient. One thing I forgot to say at the beginning is that Comau is today a global company, but the heart of our R&D is in Europe and is in Italy, where the company was actually founded. Completely different approach, but in unstructured environments, is a system for welding in shipyards. This was actually developed not with European funds, but with private funds. So there is R&D going on also where Comau and customers get together and co-fund programs. And here basically this system assists welders, which is a very scarce resource today. People that have the competence for welding are in big search and are not available on the market. Here again, this does not substitute the user, but the user supports the machine and oversees the machine but the level of quality of the resulted weld seams is much higher, and the safety of the operator is greatly improved. In conclusion, our objective is to be able to allow and access to automation to a wider public, and we have done this throughout the years through innovation programs, through training programs, which are today available on industry. I hope I was sufficiently clear and gave you an overview of how we have approached the twin transition, keeping it human-centric.
Excellent. Thanks very much, Ennio. In a moment, we'll try and delve into some of the details. We'll have a little bit of a conversation between everyone. So I'd like to welcome our next speaker, Weimar, who's going to talk about the human-centric approach to this twin transition.
Yeah, hi everyone. Thanks for having me here. I'm Weimar Bolhuis. I'm director of TNO Vector, Center for Societal Innovation and Strategy. I will tell you a bit more about our the way we work and the people we have. We're part of TNO, which is the Dutch RTO. At TNO Vector, we mostly work with people with a gamma background. So we have economists. We have, of course, people with a background in public administration, business administration, governance. So that will color the presentation I will give here today. So, the human-centric aspects of the twin transition. And what I want to stress is the importance of innovation ecosystem cooperation, and especially the cooperation cross-border, inter-regional of different ecosystems. And that we actually need that here also for the twin transition, because at the moment these collaborations are actually not really structural, not really sustainable, maybe even not really existent. And it's something we really need to develop in Europe. If we want to really achieve the goal of a human-centric twin transition. So, first thing to share is that, of course, the twin transition has a digital part and a sustainable part, but at the moment there are very different understandings and types to address the human-centric aspects of the twin transition. So, first, in this speech, I will move away from the technology, right? I will have the societal aspects, societal consequences. And that's what we see here. So on the top right, you see the discussions we have at the moment when it comes to the digital transition. And then, of course, the whole focus is on privacy, is on inclusion, is on safe data, responsible AI. And that's, of course, very familiar with all of us sitting here. We had very nice discussions the whole day. When it comes to the Green Deal or the sustainable or the green transition, there is a different debate. The debate there is about a just transition, about the fair distribution of burdens and the cost when you make this transition. And at the moment, we don't have the language yet. We don't have the vocabulary to connect those two worlds. And that's very important. Of course, both topics are very interesting, very nice fields to explore, but how are we going to combine these two worlds? I think that's very essential. And that's where the work we do as TNO Vector comes in. Just a short summary. We were launched last year in June in the Netherlands. The main reason was that TNO said, well, technological innovation is, of course, essential key. It's the starting point of the transitions and transformations we want to make in the Netherlands and Europe. But we see that there are aspects missing. And that's why TNO Vector, you see our vision here on the right side. TNO Vector's mission is not only to focus on technology. You, of course, have the social innovation coming up as a topic. But we said, well, what we need is also societal innovation. So we need to change society. Of course, we know that technology has an effect, positive and negative, on society, but we also need to think about how do we change society in such a way that we make the best of the technology available, and how we're going to make this, for example, the twin transition. We focus on several areas, but as shown there, on green and sovereign industries, on sustainable cities and regions, on value-based digital societies, also innovation systems. And it all accumulates when you talk about the twin transition. Yeah, and societal innovation, well, you need to think about governance, but also how do you analyze the problem at hand. So we see systems not only as technological systems, but as a societal system, as a social, technical system. You need to analyze, you need to find the tipping points to make transitions. So that's the way you analyze the problem. But also, what's very important, a type of societal innovation is to create new ecosystems. And also for the twin transition, you really need new ecosystems. We have a methodology, it's called orchestrating innovation, and it's about fostering, bringing together the new networks, the new parties, public and private, you need for this transition. And for example, adaptive governance. So you know, transitions are, of course, very insecure, very unstable. You don't know which way they will develop. So you also need to be adaptive in the governance you have at hand. And if we look at the definition of human-centric, it's not only about the uses of technology, it's also about the impact on others. So the impacted persons. I'm an economist by training, and we talk about external effects, positive and negative. And of course, you see that now in the public values in the digital domain, and also when it comes to the just transition in the green transition. Then, I think there's one thing that we actually really forget. Also, we need an innovation ecosystem that actually supports the twin transition. And you see, of course, that the Digital Europe program that always needs cross-border cooperation. Yeah? We have the examples, the HPC, the TEFs, and the ADs. Of course, they're in development, but what can we learn there for the twin transition? We have a great project, which I will elaborate a bit more on later, the Bowie project. And when we execute this project, you have a few lessons which are really important, and they stress why you need interregional collaboration. So first, if you have the collaboration, you can easily access leading-edge technologies and skills at the European level. You can share that. You can initiate and support together through Europe new business opportunities and new markets. And of course, share good practices. You can facilitate cross-border synergies and complementarities. Well, there are many different advantages you get from this cross-border cooperation, and that's a really vital part of our success, also for the twin transition. And that's why we wanted, and it's a project we did from 2020 to 2023, the Bowie project, the Bowie corridor. Bowie stands for the Boosting Widening Digital Innovation Hubs. That was part of the widening project, of the widening pillar. It consisted of 11 partners, and it was an 8 million turnover budget. It was really interesting because in that project we developed a methodology how you can foster this interregional cooperation and this collaboration. So first, a methodology with 5 dimensions how to address or grade the collaboration, but also multiple actions you can take to foster and grow these interregional and cross-sectoral or cross-border collaborations. And I think this has ingredients also for the twin transition. So we designed actions, services, and KPIs for all the dimensions of these cross-border collaborations, and also the different levels and what you should do there to foster the innovation. And what's really special there is that if you want to foster these cross-border cooperation or this interregional cooperation, what you actually need is a really human-centric aspect of building these corridors. So we designed an entire training and also a coaching program to force these corridors. And I think we can draw lessons from the training and the coaching programs for the twin transition. And that's I think one issue we can learn here. So if we want to forge cross-border collaborations, also in the twin transition, human is key. And we're also now developing or launching the DNET, so the Digital Innovation Hub Academy, to develop skills for the innovation ecosystems, cross-border cooperation. And I think we can use this academy also for other aspects of the twin transition. So if we look at the twin transition, we first have a very nice conclusion. You have all these different approaches to address the human-centric aspects of the twin transition. So digital is most on inclusion, on privacy. Now you look at the green transition, it's most on the fair distribution, the justice. So that's really nice, and you want to research that, and you want to combine that. But if we want to increase the impact of our technology, of our work, we also need cross-border innovation ecosystems, and we need to develop that also for the twin transition. At the moment, these ecosystems are lacking. And therefore, you need methodologies. It's not technology, but methodology, societal innovations, so orchestrating innovation, adaptive governance. And we, as the Innovector, together with partners, are so launching the DNET Academy, and we can use that academy also for the twin transition. And we're very looking forward to use this academy. But then, of course, you also need it in the Horizon projects and Horizon funding and Horizon innovation policies. And at the moment, that's not always the case. So what we urge is that in every project, orchestrating innovation, so forging a network, cross-border, interregional, should be part of every new project. And also that we need, you saw the example, Bowie, it was funded via the widening pillar. We also say, well, we need dedicated support in the coming innovation funding programs and policies, also for these more societal aspects, so fostering the cross-border collaborations. Thank you.
Great. Thank you very much. Perfect. Thank you. So, and our final speaker on this side will cover the nexus between sustainability society and technology. Ilias.
Thank you. Question. What is the goal of digital transformation? What is the goal of digital transformation? It's one of the mega trends. Okay, let's make it easier. What is the goal of the green transition? It's our survival. It's triple crisis. It's not only climate change, biodiversity, pollution. Those three together, green transition is about how to tackle them, basically for our survival. Okay, we got that. What is the goal of digital transformation? Is it about our survival? Are we doing it to survive? No? Anything else? Are we doing it to make some people from rich to super rich? Maybe. Are we doing it so we don't see our kids? How many of you have teenager kids? Do you see their faces? I have 2 daughters. I don't see their faces. They reply just doing this, you know. So is it about our kids' safety online? Maybe not. Is it about our democracy? No. So what is the purpose of digital transformation? It's not so obvious. 30 years ago, Morten and I started that in a commission. So I started as a young, full of ideals, policy officer. Morten was already there. And we started writing what is the purpose. You know what the purpose 30 years ago was? The well-being of people. Well-being means also economy, because economy is just another word for security of us as human beings. So it was about well-being, and we were thinking about economy, society. I was very much into healthcare, but transport and other things. So it's about well-being. That was 30 years ago. Did we get there? Did we get what we wanted to 30 years ago? We were writing the narratives because it was just when web. Did we get there? Everybody goes, you know, why this? What was missing? The governance. If you let digital completely laissez-faire, Wild West, you get all kinds of things. You get very good things, and 30% of people didn't lose their jobs during the COVID in Belgium, but you get very bad things too. Because we just let it go in the name of innovation. Just don't put any boundaries to digital. Just let them innovate. Well, this innovation, we are now running as a commission to create Digital Services Act, Digital Market Act, Digital Cybersecurity Act, AI Act. What are we doing? Running after the facts to try to constrain, to put the genie back in the bottle. So we have these 2 mega trends. My job is to try to make them synergize. What do you think is the impact of digitalization on the environment? What do you think? Is digital more of a solution to climate change or more of a pollution? What do you think it is? It's both. Which one is stronger? Which one is bigger? Is it the solution that does cut more emissions, or is it the pollution that we actually create? 50-50? Well, I tell you one thing. We can measure the pollution. So it's 9% of all the electricity goes to ICT. 3% of all the emissions are due to ICT. ICT is the biggest e-waste, I mean, it's the biggest growing category of waste. I tell you one thing that you should know. For you to keep your mobile 1 year longer, just keep it 1 year longer between now and 2030. So if you change it every 2, change it every 3. If you change it every 4, change it every 5. Just keep it 1 year longer. In Europe, by 2030, it's 1 million cars lifetime emission. Just mobile phone for 1 year longer. Just mobile phone. I'm not talking about iPads and tablets and servers and data centers. It's huge. We can measure that. You know what the narrative is about the solution part? That we can cut 15 to 20%. So we are 3%, that's how bad we are, but we can cut 15%. But do you go through ever those texts, you will see one thing. Can cut. The potential is to cut. The maybe in the future we will be able to cut. Blah, 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 blah. Show me one proof. Because we have no metric to measure the positive impact. So it's a challenge back to manufacturing. Do you have a proof with your robots, proof with data, how much environmental net effect did you have? That means you have to count LCA of all the digital that you put in place, because that's production, embedded emissions, use electricity. Count what is the footprint of that nice solution in manufacturing, and then count what is that you saved as material, as electricity, as energy. Have you done that? Can you say, this is the net effect of my digital solution?
No, not the net effect.
Have any of you that will present in the future, have you cut these solutions that you will present and say, yes, my net effect is positive? Nobody does that. So we are in this world of solutionists where digital is great, just put 5G in Brussels and the world will be greener. Just trust me. That's where we are. Because nobody knows how to measure anything and nobody actually cares. Just trust me, just digitalize and you will see it will come better. So if I want to show you one slide, it's the following. Our commissioner, our president of the commission said, those two are the strongest. But you know what in reality happens? They live happily on their own planets. Those two transition ecosystems, the stakeholders couldn't care less about each other. But we as a commission said, they are synergizing. No, they must be conflicting. They don't care basically. They are sitting in their corners. So how they translate this priority of twin transition, that green and digital people are more equal than the other people. That's basic translation by majority of the stakeholders. What does it mean? When there's the money on the table, recovery fund, 700 billion, the green guys comes and eat 40% for me. The digital guys come in, say 20% for me, and the rest is for the other transition, demographic transition, for example. The rest is for them. That is the translation of the green digital transition, that we two of us are more equal than the others. Now, what if I had to keep in your brain one slide, and that is this one. Keep in mind that sustainability is a three-dimensional world. The dimensions of sustainability are economic, social, environmental. What is digital contributing to when it comes to sustainability? Where is digital really powerful? In which dimension? Which dimension digital does really progress? Economic. For 30 years, digitalization cares about one thing only, economy. What does it have to do because society is not happy? That we just heard. Social issues, inequalities, access to digital skills. There's so many social issues that came up last 10 years that we are running after to make sure that there's nothing major happening so the economy can continue. What we were completely oblivious to for the last 30 years until 5 years ago, we didn't even care. That nowhere in the narratives was anything about, oh, there is environmental impact of everything I'm actually doing. So this is just a new kid on the block. What is happening today? Everybody's excited about this new dimension, so everybody will present my robots, my precision farming, my smart building system, or my smart grid system will solve the environment. Okay, prove it. Nobody proves it. But then mayors get even on the white horse and say, I will forbid all the cars, I'll just allow electric cars in the city of Brussels. Okay, good for environment. Well, what are you doing? You're killing the social issues. What I'm trying to say, digitalization and the world at large does not know how to optimize in 3 dimensions. So when you take a digitalization project and you say, I have to bring benefits on all 3 dimensions at the same time, nobody knows that, not even TNO. Sorry.
Oh. We don't know that yet. We don't know that yet.
There is nobody in the world that can tell you this project that you're trying to do about connected mobility in Hamburg. There's the Moya project with Volkswagen. Or this precision farming you're trying to do in Italy. Any digital project that you will hear cannot tell you that I have optimized and I have the best possible outcome for economy, society, environment, at least no harm to environment. It could be that you do very good things for economy, but you should not do harm to environment or harm to social issues. Nobody can do it. And that's research. So you want to have your guys doing PhD, that's a good topic for you guys. Thank you.
Thanks very much, Elias. Great thought-provoking presentation. So I'm just going to take one question, or I'll ask one question to the 3 panelists. So where do you think is the opportunity to connect the economic, the social, and environmental? Do you think it's a complete exercise in greenwashing, or is there an opportunity to link to the environmental aspect?
To me, this is huge opportunity for business. Business, I can show you a slide, actually, if it's still on, I don't know. No, it's not, that's the next one, sorry. Business wants to be green. If I talk to CEOs, one of the top priorities they have is just, I don't want to be seen as a non-green company. This sells. If I can show that I'm green, it sells. So they will do anything to show that they are a sustainable company. But to be sustainable, there is something called scope 3. So they have to move to something that is very difficult, and that is circular business model. I give you an example. Product as a service. Instead of making money, selling natural resources, materials, to sell service. Instead of selling cars, sell mobility. Instead of selling pesticides, sell health protection of the plants. And if you do that, suddenly everything turns around and the materials becomes something that is your expense and you don't want to use as much. So if you are agricultural producer of agricultural products and you go, give me X amount per hectare, you will be incentivized to put all the intelligence, drones, satellites, IoTs on the field so that you use as little as possible pesticides, herbicides, fertilizers, whatever, because it's your cost. And that is a power of digital where you can say, my scope 3 is really low, I'm doing good things for environment, and it's very profitable business.
Great. Just a quick question to Ennio, and we'll speak with Dr. Lucas in a moment as well and revisit some of these ideas. But is that something that you see reflected in your own kind of business thinking, corporate strategies, when it comes to the twin transition?
Yes. I see it, yes. As I said earlier, Comau doesn't look as much inside as being green, because we believe the effect we can have with what we provide is greater than the greener than we can become internally. But I think obviously we don't have a holistic view as Elias was talking earlier, but we believe that the three things, the green, the digital, are connected together with the human-centric within, or this is what we strive for within the solutions that we develop, and from the indicators that we are measuring ourselves on, it is giving a contribution. It won't solve it.
But it's going in the right direction.
It's going in the right direction.
Okay, well, thank you very much. We'll come back to you in a moment, but this is the end of the first part. We'll bring the two sections together in a moment. I'd like to welcome the presenter of the next slot, which is Professor Bram van der Brocht, who's going to present Sustainable Robotics in European Innovation Programs. Thanks very much.
Yeah, thank you. I'm from the University of Brussels and affiliated with IMIC, and he will indeed explain how we went from self-healing materials towards sustainable robots, but also how we used European funding to gradually increase the TRL level. Because our world is more and more depending on currently non-sustainable plastics, and we produce 460 million tons of it, where 91% are not recycled. And this is, of course, a huge problem. And also robots, of course, are very complex systems. And so when they're broken, we need or to go to costly repairs, or they add on to the increasing pile of e-waste. And so that's why policymakers are imposing new laws like the EU Green Deal and the plastic strategy, and also, for example, the right to repair. But imagine that systems, the robots, have the ability themselves to repair. That would generate a new trust in those systems. So in our lab, we generate a lot of robots where we hope to contribute to the Sustainable Development Goals. We're in the EU project SOFIA, where we improve ergonomics of workers by cobots, with, for example, use case here for Handcamp, but also we do it for Volkswagen. You see at the demonstrations our spin-off Axillus Bionics, which makes bionic feet to improve the walking of amputees. We're also founding a new spin-off company, Husk, for occupational exoskeletons, for workers that have to work a long time above the head or to lift heavy boxes with active exoskeletons. And we are also thinking to set up a spin-off company for sensorized interfaces to better monitor the human interaction forces, for example, for exoskeletons and rehabilitation robots. And a constant in all those robots is that we use elastic materials and soft materials inspired by the human body, because that is very good for energy efficiency, because we can store and release energy, but also for safety. But of course, a very famous example is Baymax, a favorite Disney movie, of an inflatable robot. It was inspired by a working prototype of the Carnegie Mellon University. And during his adventures, Baymax got damaged and uses the tape in the police office station to repair itself. But humans and animals have an incredible capability, and we are not overdimensioned. We don't use too much protections because we have the capability in many cases to heal wounds and fractures. And so that was our dream. Can we generate a robot that is able to feel damage and to repair itself, a bit similar like animals and humans? And so for that, it was a dream. So we asked the European Innovation Council Pathfinder, at that time it was called still FET Open, where we brought in material scientists, robotics, and AI persons had to build this new type of robot. So it was at that time groundbreaking research, and here you see a universal gripper, so it doesn't need any intelligence to grasp different objects. It's a membrane, a soft membrane, with something in that becomes hard when under vacuum, and like that you can grasp a lot of objects. And of course, here we exaggerate by taking a cactus because it will damage the material. But for example, there was a startup in the United States that went bankrupt because their gripper could only do 50,000 grips before the material failed. And also the German company Formhand, for example, they cannot access several markets because they're objects with sharp objects which damage the material. And so here we developed the self-healing material, so we can damage the material. It's sensed that there is a damage. Here we use an internal heater to trigger the healing process, and then you see that the material is able to heal itself, so the system can go back to action, and so it repairs its own wood. It's not growing material like humans, but the network of the polymer is internally repaired. And so to do that, we had to completely innovate the value chain. So we went from new materials where we can different mechanical properties to it, because also in our human body, we have stiff materials like bones and nails to very soft materials like fat and muscle tissue and so on. And moreover, we can heal them together, so the interface is perfect. While other materials, we need to glue them together, or other combination methods, which were usually the stresses and where the material will fail. Moreover, we investigate a lot of processing methods, so we can both do the thermal processes like printing and so on, and molding, and even combine them. So we can mold something and print on top, and again, the interface is perfect. We can also make fillers in it, so we can make them conductive, so we can make sensors with it, so we can sense when we grasp something, but it can also be used as a heating element in order to start the healing process, in case when we want to control when the healing takes place. And we also, of course, demonstrated in several soft robotics demonstrators, and here you see an example where it's healed at room temperature, so we damage the finger, and it's a pneumatic finger, we take it out, and after a few seconds, the material has enough strength in order to return back to action. And moreover, we do the simulations on the whole value chain, so that you can see for a certain product which material properties are needed and which design is needed. So the sustainability starts, we have a robot finger. If it's damaged, then we can repair itself, so extending the lifetime of it. But if we don't need the material anymore, or the damage is too high or too severe, because we cannot grow new material, then we can both mechanically but also chemically recycle it, and it's a network polymer, and a network polymer typically you cannot recycle because the network, that's why a tire, when you elevate the temperature, it will burn We see it in the street protests a lot, but so it cannot be recycled. Moreover, we're investigating biosources like castor oils instead of fossil oils, and also we check biodegradability, that when it ends up in the environment, it degrades. And so the next step is, after these fundamental breakthroughs that we realized, we went to a Marie Curie training network where we collaborate, we raise 15 early stage researchers, which all do secondments in companies. So for example, Reza is working, for example, with the company Festo to make their grippers of soft materials also self-healing, and he brought several innovations in it. We also want to accelerate research, and that's why we're in the EU project EU-Robin, which is on a network of excellence centers in robotics, because we have capabilities to make robots out of it, but many other labs in Europe have many other applications that can use this technology. So the core is patented, and we have also some trade secrets, of course, but then we open the interfaces, how to use the materials over tutorials. We wrote a paper about it, and we give workshops on it, so other researchers and engineers can start using this technology. We also made a child version of it. It's not using our self-healing technology because we think it's important to also raise new generation of scientists and engineers. And during weekends at I Love Science here in Brussels, for example, hundreds of those fingers were made. And we thought, shall we not attract more and get inspiration for the children by making a world record? It was not accepted by the Guinness World of Records, but we were accepted by making the longest chain of robots. And so during the Nerdland Festival, a lot of children, but also adults, grandparents, and so on, helped building robots, and we got the record of longest chain of robotics built in the world. One of the things is how we bring this to the market. And of course, you know, the value of death for low-tier research. There are several resources, but then it's a bit too fast. We still have now the lab demonstrators, but how we can demonstrate that in the real world? But that's, of course, for investors too high risk, and that's why we're very grateful to have the AEC Transition Fund, which was Shinto, in order to bridge this gap, to go over the value of death, and which partly maturing the technology and also developing the business, going to field tests and so on. Because there are many applications possible, it's really a platform technology, so that's why, and the videos are not starting, so we're making sustainable suction cups that also self-close, so they consume much less energy consumption. We can have much more stable grasping because of the multi-material aspect in it. And we're also looking for self-healing tires. I'm here with my bike from the Brussels startup Cowboy here, but I got often a leak in my tire in the middle of the forest. That's why we're also developing self-healing bike tires of it. And so this is only possible by a very big multidisciplinary team of both material scientists and robotics and AI researchers, but also the business developers are important in it. So thank you for your presentation, and thanks for all the funding opportunities.
Thanks very much, Bram. Thank you very much. So now I'd like to welcome Dr. Corinne Lucas to the floor to speak about sustainable digital transformation of SMEs.
Hello. Yes, thank you. So my name is Corinne Lucas. I work for Agoria. We are the sector federation of the technological industry in Belgium. We group over 2,000 member companies, both in digital and manufacturing. And I was asked to talk about twin transition with SMEs, and I really want to bring a bit of a different story. I'm no longer in the real research cutting edge. I'm really in the trenches with a lot of the SMEs, so I want to focus today not on the, say, 10% really innovative SMEs who are here as well and get funding for innovation, but on the large group of SMEs who are trying to get by and grow and move forward every day. And there I agree, I was surprised to hear you talk. Twin transition to me is also a bit of an odd marriage sometimes, because I always say in green the goals are clear, but the companies don't really know how to get there yet, but they want to reduce energy use, reduce carbon emissions, maybe move to a circular business model, but that's a very complex transition. It involves the entire value chain. But in digital, typically all the technologies are there in abundance and you can read about it and follow the hypes, but the goals are not clear. And SMEs are really struggling with that, and when we are working with them within EDIH programs, but also other programs, we always encounter similar problems with digitalization projects at SMEs, but I dare to say big companies suffer from the same challenges. I think there's three big challenges that the companies face. The first is seeing the forest through the trees. We really see a lot of technology push, and we have to do digital transformation. Why? So and then we have our AI project or our ERP project, and then we come in and we ask, but what is the goal of the project? And there's really no answer. Or maybe that's even worse. Sometimes you get 5 different answers if you ask to 5 different people in the company. So we really want to push saying digital is technology that's enabling, that can help with a lot of things, including your green transformation, but you should only use it to solve clear problems, to really support people in their jobs. The second problem that we see a lot of SMEs facing is that the approach that you need to take to be successful in digital projects is different than the classic engineering approaches or economic planning approaches that we all learned. The people we talk to in SMEs typically have no experience in digital projects, and we are all trained as engineers or computer scientists or economists, etc., in planning, and we have a planning and a budget and a Gantt chart, etc. But digital projects don't work that way. To be successful in a digital project, you need to take up more of a design approach, because the success of a digital project is not in the technology. It's not like being able to box off a list of features that we have implemented. Success is only there when you get people to really adopt the technology and to have a feeling that it helps them in the job that they are doing, or maybe in your free time to book a holiday or do your administration or anything. Because a lot of digital projects are ended up by delivering something that people don't enjoy using, and you go back a half year later and there's still Excels going around by email. So success in digital transformation is adoption on the floor, it's with the people. So human-centric digitalization, there's no digitalization without being human-centric. But that's something that's very difficult for people in charge of projects in SMEs, because we can't promise them, yes, 2 years and that budgets and that's what you're going to get. You have to go step by step with the people. And then the third part is effectively the teams, the people that need to do it, the skills that they need to get to work. We need multidisciplinary teams, and you have to work with technical people and the potential users together. And it's not possible to throw a list of requirements over the wall and let them implement it. You have to work together. Therefore, you have to understand to some extent what others are talking about, what others are doing. So we need, there is still a learning curve there. We get a lot of questions. If you look at EDIH, we are linked to the universities, but on the other hand, we get questions from companies of 10 people who really want to do digitalization of administrative processes, and they think they need a fully customized implementation project that they can afford. So there's really still a lot of effort to be done there. So that's what I wanted to say. I think we as a community also have a responsibility to try to explain to everybody as good as possible what is possible with digital technology and what is not, etc. And maybe one more remark I have to answer, because I stand here also from the Technology Federation, and I do agree with you that from the digital, I represent digital companies, from the digital industry, I think the last decade we didn't really look at environmental issues. We lived in some kind of, with our head in the cloud, where we thought everything is in the cloud, and we didn't see like a tractable things with it, and we thought there's no impact on environment. It's going slowly, but I really see a movement going there. We have master classes on sustainable IT, etc., and it is slowly picking up, but there's a long road ahead of us. But again, we say, and I'll conclude on that, you have to use digital technology for a purpose, and we see there one of the purposes is definitely using less energy, etc., also for financial reasons, but that's okay. One of the purposes is working on inclusion and diversity, also because there's a lack of talent and they want to attract talent, but it's okay. We do see a lot of ambitions there, and I think that digital technology can help there. That's what I wanted to talk about.
So, thank you. So just a quick, before we move into a quick question, I'll have a little bit of an exchange, but do you really see the kind of new emergent SMEs as having core drivers that kind of cut across the three issues that were presented before? So are they really driving towards like environmental solutions, or are they really considering these within their business planning?
We definitely see companies, and then in digital, like SaaS companies effectively, who have environmental or societal goals that they want to help achieve through the digital technology. To have the two combined is yet another thing, but it's definitely coming. Yeah.
And something that I wanted to question before, but how do you break the barriers between disciplines, various disciplines, and create new ecosystems? Because that's effectively what you're doing on a slightly smaller scale. This is happening on a kind of regional level. This is happening across a large organization. So what are the practical steps that you put in place to try and do that?
What we try to do is we've tried to build very easy models. We also wrote a book on it, but it's in basic language explain what digital projects are like, and without going into the technology, but how do you work it? What is Agile really about? It's really about working together with your potential user, etc., etc., and then put people multidisciplinary together at the table. But if your ambitions and your goals are clear, then you can talk together. But if the goal is our ERP project and everybody is sitting there talking and they don't know what they talk about, so that's really a first step, I think. Well, they don't know what they talk about. They all have a different idea in their mind of what they are talking about.
Great. And from this side, do you have any, I don't know, what in particular approaches that you take on the regional level, Weimar, to break across those barriers and create those new ecosystems?
You know,
because really, it's tough. It's tough.
It's really tough. What strikes me when you look at the digital transition and the digital innovation experts from the technology side, they always focus on the users. And when you only focus on the users, it's of course it's historically, and you totally understand it, but you miss that there are also external impacts, effects, social effects, environmental effects, and that's really, I think, something we need to cure together. Because that's just the weak side, I think. And your presentation was really nice with the three pillars and the three ecosystems, but there was no answer. How do you connect those three? And I think that's a real issue. I think that comes to my presentation. It was a bit off of the other presentations, I totally agree, but it's about how do you connect these ecosystems. And I think you really need a policy there, and also policies, networks, cooperation. And it's a different task than indeed the technology or agile or user-focused.
I think there's a difference between big companies and small SMEs, because SMEs are not on the radar of our legislations that deal with CSRD, corporate social responsibility, corporate sustainability reporting, and all that stuff. But in the big companies, traditionally there was something called CSR, corporate social responsibility. Slowly they understood that there is this green thing, so they created a chief sustainability officer. Now, if it happens to be the same department, fine. If not, there are two different ones. And then there are business people and say, oh, just shut up, we're making progress. And so until all this elevates to the board level discussion, it's not all the companies happening. But there are some that it's already happening. And I talked to about 70 biggest companies there are in IT. About 40 of them, the CEOs understood the power that they have to combine sustainability and digital model. And we are working, and we have something called Green Digital Coalition, and we developed the methodology how to do the economy and the environment together, but not yet the social issues. And that's where we see a biggest challenge, because the social issues are the least, they are the softest.
Yeah.
In terms of, in environment you have LCA, you can measure energy, materials, CO2. In social issues, it's difficult to get metrics that are precise enough to do modeling and optimization. And we pay the price because the farmers out there are exactly that. We go so fast on the green. Oh, I know what to do with the green now. I will cut 30% of the fertilizers. I do this, I do that. And I'm so excited about the environment that I forget the social issues. And we pay the price. So all the farmers out there is a proof of how fast you go from economic to environmental dimensions, and you optimize, and you forget that there are people in the middle of it.
Great, thanks very much. So at this point, I would like to welcome up Professor Antonella Monti, representing Fraunhofer and RWT Aachen, who will talk about the smart grids.
Yeah, in the next 10 minutes, I will try to answer the question, are we moving from research to reality on this topic being around for a while, and which role digital solutions play in that context? I think all of you know we are going through a huge energy transition, and if you look at what's happening, in reality, everybody to solve the problem of decarbonization and say, we'll make it electric, which is good for us. I'm an electrical engineer, I'm happy to be at the center, but at the same time, this is bringing tremendous issues and challenges in operating the power grids of the future. That's what we come the term smart grid, and it's this transition from a quite simple infrastructure, simple in the principle, not in the structure itself, that was in the past in a kind of unidirectional flow of energy from big power plant to homes, to a system now that is way more complex, multidirectional, that is what we call smart grid, or digital grid now. It's becoming more popular than smart grid if you look at the words you hear around, but the reality is changing dramatically the way we use the infrastructure. And this is due by the fact that because of decentralization, we don't have anymore this universal flow, unidirectional flow of energy, but we have a very much more complex flow of electricity in the system, and much more electricity because everything is becoming electric. And here is where digital is critical. Why? Because if we try to apply the principle of the past to the new solution, we will need to expand our infrastructure to a point which is economically and environmentally not sustainable, to the point that the International Energy Agency in Paris has calculated there isn't enough copper to make the planet green if we continue with the same principle. So we have to dramatically change the way we use the infrastructure to make sure that the copper in the ground does the job at 100%, which is not what is happening today. The good news is that all the new systems we are installing, PV, wind, and so on, are smart systems, intelligence in nature. They have a lot of data, they have intelligence, and the point is how we make use of this intelligence and this data in a smart way to benefit the infrastructure, so we have a societal impact, environmental impact at the same time, limiting the need of infrastructure expansion simply because we cannot afford it. And this has been the topic of research for many years. People talking about this complex flow of energy and data and how this can be harmonized. And there'll be a plethora of funding for the European Commission to reach a vision on smart grid. In my view, the good news is that finally we are coming to results. So after many years, and we have been testing small proof, and here and there, we are coming to new methods and approaches which are becoming real. So in the next few minutes, I will try to give you some examples on how, from funding, we are moving to reality, so that we have a hope that this transition can really take over and move forward. And I'll use some example. This is a project recently closed Platone. And this is a specific use case, very interesting for these different pillars we were discussing before. One of the key elements of the energy transition is empowering citizens. That's the social aspect. Giving the possibility to citizens to organize themselves. There was a fantastic regulation for the European Commission to facilitate the so-called energy community, but they have to work in the infrastructure. Building a win-win business case between the energy infrastructure and the community is an underestimated problem. In this project, thanks to a concept of energy platform for the grid operator, we built a possibility for the local energy community to expand their capability of self-consumption of their local renewables, while at the same time, with the synergy with the grid operator didn't have to expand their infrastructure. So both benefit, instead of being in a sort of competition, and the digital solution in making sure that the local infrastructure make the best use of the energy without affecting the large system. Because the old model was, let's just push the energy into the grid, wherever it goes, I don't care, somebody else will use it. No, let's keep it local, minimize losses, use our energy where we need it, but without creating a burden to the system. This small community, which is in the north of Germany called Twistringen, has been the first instance within the European project. Now, with the support of German funding, we are scaling this to more communities using the same solution, the same architecture, based on an open source platform developed within this project. And I will come back to this open source point, and making sure that other communities in the region will go in the same direction. Other interesting case, coming from the same project, city level infrastructure is one of the most difficult one, also because finding space for those solutions is particularly difficult. And if you're in the city of Rome, you have another challenge that whenever you try to find space, you find Roman ruins that will stop your work for 10 years. And that's where the city of Rome thought, we cannot go ahead with the old way. In this project, they use the same platform they use in Twistringen to start restructuring their system, so to avoid large investment in grid expansion for a simple economical reason. They couldn't afford it. It was too expensive to be ready for Rome of the future, just going for the classical solution. So the digital not only is avoiding investment, and investment means also material that we waste, but also making things that otherwise would not be possible. And what is nice here, that again, thanks to this open source concept of automation that was developed, they're now moved to a production. So it's not anymore a research project. Now the city of Rome is officially, thanks to funding also connected to the recovery funds in Italy, moving the project to production. So the whole city of Rome will adopt this solution, and that's an effort they call Rome Flex, enable the first idea of real implementation of flexibility market in local sense, and make it the city of Rome ready for the 2030 without large investment in the infrastructure. So with a double return to the community, to the economy, to the material, thanks to software and digital solution. But we need to scale higher. And that's another project that is going to end in a month. We'll have a final event here in Brussels. We need to systematically bring together all the different infrastructure in European vision. That's because my possibility of accessing solutions in the energy system should not depend on where I'm sitting in Europe. As a citizen, I have the right to be able to use the best energy services wherever I am, and to be able to participate to whatever market I want, to whatever solution. And that's the principle behind the OneNet project that's been developing standard data exchange mechanisms starting from solution based on data space technology that is now being deployed, and here where it becomes real, not in one small field test, but making a project quite complex with several, like 15 countries involved, that many of the grid operators in Europe are running the same interfaces now as a result of this project, so they're all ready to build a single market of energy because data can be shared among operators, facilitating flexibility market independently from the countries. And also here, the decision has been, at the end, the key technology, the key software is released as open source so that it can survive the project and community can feed the evolution and the application. And the same principle, I mean, here you see this, the countries which are colored are the ones that, using this project, are already installing this software that will make possible this data exchange, and so that from there to a European adoption, the steps are quite short and not possible. And so projects survive the funding period. And they're actually going forward because the same technology is now driving a new project starting this year called TwinEU, with the purpose of building a digital twin of the whole European electrical infrastructure, using the same technology of the previous project and expanding to the concept of digital twin. Well, why do we need digital twin? To facilitate fast decision on investment. I want to build a new power plant. I don't know if I can do it here or there. I don't have access to the data space principle, and a European view on digital twin will facilitate investors to understand where it makes sense to invest, working directly with the grid operator across Europe. Again, here, the open source solution, the previous project, are facilitating a fast transition in the new project, in a new, larger use case. And that's the point, one of the key decisions that have been taken and accepted in the energy community have been the use of open source to facilitate the continuation of effort beyond the project and the cooperation. Here I'm mentioning two, Linux Foundation Energy, which is driving all the previous cases, and CRESIM, which is a new association funded by industry completely to facilitate cooperation on open source projects among research centers in Europe. All those focusing on energy use cases. With that, raw data is growing and digital solutions are emerging and are facilitating new principles to run the power grids, which are critical to support our energy transition. Thank you.
Thank you very much, Antonella. Thanks very much. I'd like to welcome our final speaker. We're running a few minutes over, but I think we started a bit later as well. So it's Peter, please take the stage. Peter van der Steen is going to talk to us about the digital twins for building renovations. So another example of where you're bringing several communities together.
Indeed, I'm also giving it a go to bring together these three different pillars that we talked about already. It's also a digital twin environment. So we developed a digital twin one-stop shop for the specific use case of renovation in Flanders. So just Energieville, that's Vito Energieville. Vito is a Flemish RTO. We also take part in Energieville, which is a consortium, in fact, of Vito, KU Leuven, IMEC, and the University of Hasselt, working on energy transition. And we work on the buildings and districts, which is a bit an overarching team, so to say. So again, in the renovation context, what you see a lot today, and we talked about a just transition already and the social aspect of it, it also goes very fast in that sense. And the responsibility today is very much on the individual level. So every household needs to achieve carbon neutrality by 2050. We have an A label for that. And what we know already out of research and projects that we have been doing, that if we try to solve this collectively, it's much more efficient. We will reduce CO2 emissions by more at a lower cost. We know that. And so the question is, do we need to transition away from the individual responsibility towards a more collective responsibility? And so for that, we set up this research project, the DITUR project, which is in fact funded by VLAIO. That's a Flemish organization for innovation and business. And it's a very specific type of setting because you need to collaborate with industry. So it's low TRL research combined with industry partners. And so there is a tension from the beginning in this type of projects because how to combine low TRL with somehow market-ready projects, that's very hard to do. But at least here we, with several research parties like VUB, amongst others, UGent, KU Leuven, Vito, and then AGC Glass Europe and Avignon, we come up with this approach for our digital twin, one-stop shop for innovation. So in 3 different steps where we try to combine or at least try to link each stakeholder in the process to each other, because that's, we're talking about ecosystems, but an ecosystem is made up out of different actors. And you can have a public actor, you can have a private actor, and you need to link them to each other. So the question also is, who is taking responsibility into bringing these parties together? That's just an open question. But it's not also the responsibility for industry to each of them bring a solution to the market. Also there, I think there's an aspect of collectivity that we can can take and benefit from. So here in the DITER project, 3 different steps. Identify first, seeing where the opportunities are in the city environment, then engage the citizens. So we make a long-term plan for carbon neutrality in the built environment on the city level. That's that's on the plate of the cities and municipalities. Then we have the engage step where we bring the citizens into it, explain the plan, but also bring it to one address level, so to speak. In Flanders, for that, you have energy houses. That's a new kind of concept where there is a role of bridging the ambition and, in fact, provide guidance to become carbon neutral for citizens. And then the industry comes into the picture because, of course, we need them to execute the works and we also need the hands, of course, of all these people. But the data that is built up in all these different steps can be linked to each other and can be transferred one to another. So this was picked up. We were quite successful in the project because we measured it and we saw that we could increase for this small test environment that we did, of course, in the city of Aalst, but we increased our renovation rate from 1% to 3%. That's exactly what we need to achieve in Flanders to obtain our 2050 goals. So we tripled it, and we got the engagement we were able to engage the local contractors. So here, these different parties all play a role in this project because now there are 3 different cabinets that sponsor this project. Not to name them, the ministers of Somers, De Mier, and Broens. So they sponsored this project to roll out this approach for the entirety of Flanders. So every building in Flanders will have its own building physics model by June of 2024. So the ecosystem around renovation in the built environment here in Flanders, then we have Flemish government departments, we have the local governments, of course, the energy houses already talked about, and the industry players. And so for each of them, we have a different application. So we have the district renovation tool for the cities and municipalities, the building renovation tool for the people who need to engage and make the bridge to the homeowners. And then we have a bidirectional API where we can give also access to the data that we have to industry players, as long as they have a mandate, of course, and the mandate to get access to certain data that might be GDPR sensitive, but if there is consent, that's not an issue. Also for the district renovation tool and the building renovation tool, also there, local government can give access through authorization to a third party to provide guidance. For example, an engineering company that wants to elaborate more on the plan. That's all possible if you do it to public procurement. So what have we have in the background? So behind the screens, we have our algorithms and the data position that we have in Flanders. But of course, that's dependent on the region. The same approach can be can also work in other regions in Europe, but the approach that we take is, of course, top-down and bottom-up. That's the specific data position that we have. But the top-down, that's the district's angle. Again, you have a more aggregated level, and bottom-up, you, in fact, alter the data based on the input from the household, for example, here. So it's, in fact, a flow, which you reiterate again and again and again. You said that an as-is in 2024. We have a planning until 2050, and each year we can reiterate and see where we got with our plan, with these different tools that will become available, and also report on it. And so it's a tool that we can keep live, hopefully, with the support of the different public authorities. So just as an example, some screenshots of the different tools that we are building, that we are delivering again by June 2024. So the district renovation tool, you have an overview of your entire area of the city, of a municipality, and you see the as-is. What is the EPC? How many owners do we have? How many renters? what is the current state of my city, of my municipality, what is the label, and what would be the cost then to come up with carbon neutrality measures for the entire city. So that's the plan. You translate that to an entire region, from an entire region to one building. So that's really, yeah, it's kind of dry. It's just a building physics model for each building, and that's what you see here. So the energy advisor can play around with it and give measures. And this will also be rolled out in combination with the Foster project. That's a project that will help out the energy houses to align a bit the methodology. Because today, here in Flanders, these energy advisors, the quality of the advisor that was given varies quite a lot, and so that's something that we avoid. And then, last but not least, of course, we have the private actors that come into play. And so if they have the mandate, they can also get access to this data. Here, for example, you have an example of a CRM system for energy houses. If you can couple with the data, that's also something which is really handy in support of these energy houses. Or specifically the data or the application out of the DITUR project, that's from AGC, where you really had a complete platform where all the data was shown to the people needing a renovation, and where you can also make a plan towards carbon neutrality based on the income or the available income at that time. Or a complete 3D environment for portfolio management, or real estate companies that work on this, or energy advisors and the type of renovation advice that they want to give. So that's a bit my talk about the renovation use case in Flanders.
Great, thank you very much, Peter. So I know we're running quite a bit over schedule, but I did want to give the audience the opportunity to ask one question, if you had it. Otherwise, does anybody want to ask one question? We have one question here. Have you got a... Thanks.
Yes, I'd like to go back to the 3 dimensions of sustainability and the point that we've focused mostly on the economic benefits of digital. But would you not agree that on the social dimension, the fact that everyone now in our society, regardless of their income level, has in their pocket a computer with unlimited access to information, and that on the environmental dimension, that same device replaces a multitude of appliances and bulky gadgets, GPS, camera, flashlight, radio, etc., as well as hundreds, thousands of books, newspapers that are printed, that have to be stored in bookshelves and filing cabinets. That's a lot of avoided material that we don't need thanks to the digital phone.
Thanks very much.
Yes.
Try and answer as briefly as possible.
No, it's fact. I mean, this is already documented, the replacement through mobile, how many things we replaced. Despite of that, there is still growing material consumption in the categories that we thought we replaced. So still radios being built, still cameras being built, still all the things are being built, maybe not in the fashion that it was there before the mobiles. So there is a debate. This is well-identified problems, and people try to understand what is the net effect of the digital. So, and the digital companies are putting it as an argument that is very well perceived, but is not yet proven. So we still need to see what is the net effect of digital. If you allow me, I would like to make a comment on the last presentation.
Sure.
There are 2 things that are very important for you as a take-home message. First, funding. All the private and public funding institutions are saying, I want to fund sustainable things. So World Bank at the COP committed to 45% of anything they will fund will be sustainable. EIB, they would like to go to 50%. Private funding says that's where I want to fund. So it becomes trend. By 2030, maybe 75% will be sustainable funding only. Digitalization and the kind of the smart grids and this energy bill, are not yet on the menu. We have to put them on the menu. How do we put the menu? So digitalization is part of sustainable finance. If we don't put ourselves on the menu of sustainable finance, you will suffer. If you are SME, if you are a company, you will not have access to privileged conditions for financing. So how do we put ourselves in? We need a method and we need KPIs. We need to prove that we are sustainable. Our net effect through energy bill and the smart grid is positive. The net effect of my manufacturing robot is positive. That means, yes, there is materials, there is energy use, but the net effect of savings of materials and energy saving is more than my footprint. That methodology we have developed, and that needs to be used. Otherwise, even the green public procurers of each city will not scale this project. So 19 houses is nothing. Ghent has 2,000 now. But to scale it, there will be a lot of private investors and a lot of public funding. But they will not scale it because they will not be able to tick sustainable finance project. So you have to go that extra mile to prove that whatever you're doing here is net effect positive. So you get sustainable finance, including social no harm. Okay, that this is actually with the people in.
Great, thanks very much, Alyssa. I don't know, do you want to quickly respond to that, or?
Well, I don't know if you understand the concept of the 19 energy houses, but they're regionally across Flanders oriented. And so we're calculating 4.5 million houses in Flanders. So every house will have their own renovation advice. But I fully agree. And I think we need to upscale a bit the funding or the financing scale, and not at one individual level, but again on a city level. And then if we have building teams working on districts, for example, for positive energy districts or for infill projects, and you can use that new building as a trigger for an entire neighborhood to become more green, that type of financing I think is very hard to find, but we need to prove it and we need to find it.
Correct. So on that note, I think we're going to finish it. I once again thank our panelists for their time, and thank you for your patience as well.
So